Here's an interesting application of linear equations. I'm going to read through the question. I'm going to show you how to work this out in Mathematica. Okay, so it says the flow of traffic through a network of streets is shown below. So in other words, this yellow diagram here is some sort of street system. And so these big yellow circles are some sort of intersection. And notice that we have arrows. The arrow denotes the direction of the traffic. Okay. Now the thing is we can easily monitor how much traffic is coming in and how much traffic is going out. So that's where you see this 100, 200, 100, and 200 around these big circles. The traffic around the circle itself is kind of hard to monitor, the x1, x2, x3, x4. So we're trying to figure that out. How much traffic, what kind of flow do we have around this thing? Okay, so first of all, our first question says solve the system for x1, x2, x3, x4. And you might be saying, wait a minute, what do you mean a system? I don't see a system here. Okay, so what we're going to do is I'm going to label each of these intersections 1, 2, 3, and 4. And this is based upon an idea called Kirchhoff's first law. This says that the amount of flow coming into an intersection has to equal the amount of flow leaving the intersection. So in other words, around intersection 1 right here, notice that I have this much coming in. Those two things have to equal x3. Okay, so that tells me then I can come up with a first equation that says x1 plus 100, that's what's coming out, or that's what's going in, equals x3. Okay, so I know that x1 plus 100 equals x3. Or if you wanted to, you could say x1 minus x3 equals 100. Our second equation, so around intersection 2, we have one input, x3, and we have two outputs. So that's 200 plus x4. 200 plus x4 equals x3. Looking at intersection 3, okay, I have one input, which is x4, and I have two outputs, 100 and x2. And then lastly, I have two inputs, x2 plus 200 equals x1. So in part A, when it says solve the system for x1, x2, x3, and x4, that's exactly what we mean. Alright, now let me show you how to do this in Mathematica. Now that we're in Mathematica, we can quickly solve the system, and we can either take the matrix approach or the solve equation approach, the solve function approach. And I'm going to use the solve function approach because I know I'm going to have parametric equations here, and it's a little quicker to use the solve route with that. Okay, so we have x1 plus 100 equals x3. That's my first equation. My second equation is x3 equals 200 plus x4. Be sure to use double equals on your equations. I've had weird memory issues a lot when I forget to do that. Okay, x4 equals 100 plus x2, and my fourth intersection is x2 plus 200 equals x1. And I'm going to solve this for x1, x2, x3, and x4. So there we have it. I have here now notice I have x2 is negative 200 plus x1, x3 is 100 plus x1, and x4 is a negative 100 plus x1, which means I can replace x1 with any real number I want and get a solution here. Okay, now it wasn't surprising that our solutions in Mathematica would give us parametric solutions because, I mean, what kind of road system would have a constant flow, right? So these x1, x2, x3, x4s have to vary. Okay, now what we're going to do is we're going to treat x4 as the variable that determines what happens to the others. In other words, all we have to do is monitor what's going on in x4, and it'll help us figure out the flow on x1, x2, and x3. Okay, so for part B, we want to know what's that traffic flow when x equals 4. Okay, so now we want to figure out what happens when x of 4 is 0, but notice my equations are not solved in terms of x of 4, they're solved in terms of x of 1. Now to fix that, I'm just going to list x of 4 first, and now I have everything in terms of x4. Okay, now how do I figure out what's going on for different values of x4? Well, I can make a function. I'm going to call this x4, and I have 3, and I only have one variable, we'll call t here, colon equals, okay, and my function's going to be, I'm going to make a list. The first value is going to be 100 plus t. Where did I get that? That's my x1 value, right? Notice 100 plus x4 is my x1. Okay, x2 is negative 100 plus t. And then lastly, I have 200 plus t for x3. Oh yes, and there's one thing I'm forgetting. I need to put an underscore on my first t, so that lets Mathematica know. Notice when I take out the underscore, everything's blue. When I put in the underscore, now it knows that the t is a variable in this function. And now I can plug in any variable I want in for t, for example 0, and I get the rest of the flow. Okay, so that means x1 is 100, x2 is negative 100, x3 is 200, and x4 is 0. So if we look at our picture, x4 has no flow, x1 has 100, x2 has negative 100, and x3 has 200. Now for part C, it's the same as part B, but we're just going to change x4 to be 100. Okay, now for part C, we want to know what happens when x of 4 is 100. So all I have to do now is type in 100, and there I have my new flow. 200, 0, and 300. Okay, so let's look at the picture and figure out what's going on here. X of 1 is 200, x of 3 is 0, x of 1 is 200, so that means that all the traffic coming down into 4 from the top goes through x1, and x2 then provides nothing there. All the traffic on x4, because x4 is 100, leaves at intersection 3, and so x3 is very crowded because you have 300 coming in the intersection 1, x3 has 300 going out, 200 leaving at intersection 2, and 100 going up to intersection 3. I hope this makes sense. Using Mathematica to solve questions like this is very useful. You should see why Mathematica is useful. It saves us a whole bunch of time. If you have any questions on it, I'd be glad to help. And thanks for watching.